This is Floss Weekly, episode 784, recorded Wednesday, May 22nd. I'll buy you a Poutine. Hey, this week Dan Lynch joins me and we talk with Francois Preux about Poutine. That's an open source project from Boost Security. It is a code analysis tool looking for security problems in your GitHub and GitLab CI actions. Things like leaking secrets or cache poisoning or maybe even something worse than that. You don't want to miss it, so stay tuned. Hey everybody, welcome. It is time for Floss Weekly. That's a show about free, libre, and open source software. I'm your host, Jonathan Bennett, and we've got Dan the Man, Method Dan, the one and the only with us today. The original Linux outlaw. Is that right, Dan? I call you that sometimes. That's accurate, isn't it?
I like to think so. I'm not entirely sure, to be honest. I'm sure there's a lot of other much older Linux outlaws than me who would claim that. But yeah, I'm going to claim it. Why not? Nobody else did.
Now, the real question, I suppose, is have you ever actually been an outlaw?
Have I ever been an outlaw? Only speeding offences, really. In the car, I've been on a few speed awareness courses for the local police, but only a couple in 20 years. That's not bad.
That's not too bad.
Mm-hmm.
Well, we've got a fun show today. We're going to talk with Francis Preux about a project called Poutine, which that is a Canadian. It's kind of a Canadian junk food. Is it a junk food? Maybe it's not a junk food, but it's a particular type of food that is apparently very messy to eat, and so that's sort of the play on words. Poutine is about figuring out a particularly messy security problem. And this is a project done by Boost Security, and they just recently announced it and made it open source, and I thought it was neat, so I was excited to be able to talk to him about this. Is this something you've gotten a chance to look into yet, Dan?
Only today. I've been doing my research today. After you helpfully sent me some pointers, I've been on reading some stuff about this. I suppose the real question is: have you ever had poutine itself? Because I have the food.
I've not had it. I've not had it. Really, it sounds very interesting.
It's very nice. Very nice.
The unfortunate thing is that it is now on my I cannot eat that list. I recently got diagnosed with Hashimoto's, which is a thyroid problem, and one of the most common solutions is going gluten-free. So I am going down that road to see if that's going to help. And right. So there's a lot of junk food that I used to enjoy that's like I can't have that anymore because it's trying to kill me.
You need to find new ones. I'm sure you'll find new ones.
Oh, I'm sure. All right. Well, let's not dally any longer. We have the man himself. Rather than continuing to take guesses at what the project is about, let's bring Francois on and welcome to the show, sir.
Thank you. Thanks for having me.
Yeah, it's great to have you here. So, first off, did I pronounce it right? Is it Poutine? I am very ignorant when it comes to that particular bit of Canadian culture.
That's how most English-speaking people pronounce it, Poutine. But in French, it's Poutine, so a little softer on the ending.
Okay, and then give us kind of the overview, as we like to call it, the 30,000-foot view. What is this? What's the problem that we're trying to solve with Poutine?
Yes, so really, it's in the category of security vulnerability scanner. So it's what some may call like a static code analysis scanner that is going to look typically at source code, but more specifically manifest. Like typically they would be written in YAML and they would be stored on GitHub or other Git repos, not just Git, but and those YAML manifests would define build pipelines. The ones we currently support, it's GitHub Actions, if you're familiar with that, or also in GitLab, the GitLab pipelines. So they would define the way to build a certain software and eventually package and publish to some kind of registry. And with Poutine, we're looking at security vulnerabilities in those pipelines. So we can get into the details of that.
Yeah, what does one of those security problems look like? Like, what's sort of the the category of issue that people run into with their GitHub and GitLab pipelines?
So first, let's kind of set the stage a little bit. So there are kind of two broad kind of types of issues. If we look at open source projects where everything is visible, like including the build pipeline, so typically on GitHub, you can discover not just the code, but the way it's built. That is definitely an area where the attacker can, as is the case for the actual source code, find vulnerabilities, potentially like unknown vulnerabilities, 0 days, right? When it's like an enterprise setting, like an internal source code where an external attacker would not see the build pipeline or the code, would be more like insider threat scenarios. But in the case of open source projects, you can see even the dependencies that this project is pulling in, how it's built. And really the scenario, the classic scenario is, if you're familiar with GitHub, like, pull requests, the term that we use typically to address like the most common type of problem is called pwn request. Like that is effectively a pull request from a fork that is specifically targeting a vulnerable workflow. And the way to do that would be either through the actual files that are modified in the pull request. So let's say the contributor, a malicious contributor, is sending a patch. Let's say, and that is a real example, that's just updating the README, right? README.md, it's markdown file, apparently just a text file. But if it so happens that the build pipeline is going to do like a linting, formatting, just to make sure everything is by the book, that is running code like linter or whatever on untrusted data. In that case, just a markdown file. Most cases, it's pretty safe, but some tools have little known kind of dangerous features that can be exploited by the attacker to run some remote code execution. That is one example. The other way is also through all other kind of inputs that the attacker has control. Let's say the title of the pull request, or the body of the description of the pull request, or the comments, threads you see, or basically there are a number of things that if you're a user on GitHub, you can influence, and the build pipeline will consume it. Also, even the Git branch name. The Git branch name, you'd be surprised that it can contain like arbitrary bash commands or JavaScript commands. It's long enough and it accepts enough characters. There are some restrictions, but it's more than enough. And we've seen in the wild just malicious Git branch names.
Okay, let me give you a softball question. I sort of know the answer to this, but here's a softball for you to get further into this. I thought Git runs all of your workflow stuff in their hosted virtual machines. Doesn't that completely solve all of these security problems?
So I think you're referring to GitHub Actions. So GitHub Actions, yes, they are indeed by default. The GitHub Actions run in ephemeral throwaway virtual machines that are created on demand right at when a workflow is being triggered. Actually, even in a workflow, you have what they call jobs, and each job is going to be a completely independent ephemeral virtual machine. But then inside of that, typically you would be referring to secrets, for instance, to push to npm, PyPy, Docker Hub, or whatever. So as part of the execution, in the end, it gets injected some secrets that could allow an attacker to pivot to something. Like, let's say, secrets to connect to AWS to run some testing if you're developing some kind of tool that would run in the cloud. In the runtime, in the memory of the runner, even if it's ephemeral, it would get high-powered, in some cases, like sensitive credentials.
So that's really the kind of the problem space that Poutine is aimed at. Someone can get arbitrary code execution. In some projects, I will add, in some projects, the way the build system is set up, you sort of have arbitrary build or arbitrary code execution by default because, there may be a build script that just runs bash code. And you can send in a pull request that changes the build script. So, I mean, in some cases, that's trivial. It's what I assume what Poutine does is it looks for these problems and tries to what give you a warning that says, "Hey, the way this is set up, it's trivial for someone to steal your secrets."
Exactly. So typically, the way GitHub Action, namely, was designed, it was designed with that scenario in mind firsthand, because GitHub from the beginning always had pull requests with accepting pull requests from forks, right? So that's just by its definition accepting untrusted code from someone.
Yeah.
So they designed by default that this would run in a sandbox where no secrets are accessible. But in some cases, you need secrets. For instance, imagine you're processing the incoming data, and as a maintainer, you want to lower your toil of just like accepting like the contributions maybe come in a specific format, and that they meet just the guideline of the project. And in that case, then you might want to reply automatically with a comment saying, sorry, we are not accepting your contribution until you address XYZ. But for that, the script will need some credentials to push the comment back in the flow, and in some cases even update files or push artifacts. So it really comes down to limiting the amount of secrets visible to kind of risky workflows, those that you need access to some secrets, but if you really need that, then yeah, you need to not process arbitrary code effectively.
Yeah. Yeah. There's another kind of class of potential problem, and I'm real curious because I've been working on this in a project that I'm involved in. We wanted to be able to do ARM and ARM64 builds. Well, as you probably know, that means self-hosted runners on Raspberry Pis or something similar. And I have been working over the past couple of weeks on trying to figure out a way to actually do that safely. And the solution that I've come up with so far is with the self-hosted runners, you can do you can set it up with an ephemeral tag, and then what I'm doing is I'm running those inside of Docker images. But I know that like Docker images are not the same level of safety as something like a virtual machine is. I'm curious, is Poutine aware of like this side of the problem, doing self-hosted runners?
Absolutely. So we
Excellent.
have a rule that will flag the usage of self-hosted runners, which trigger which accept on pull request. And what's interesting there is that because unlike the sort of hosted runners, which are designed to be fully ephemeral, like fully like cleaned up, and there's no sharing, fully isolated between each run, in that case, you're responsible for making sure everything is fully isolated and there is no leakage between each job. Because if you have two uh, jobs that run in parallel concurrently on something you host, there could be cross job kind of pollution or sort of exfiltration leakage of data. So yeah, we do flag scenarios where you're combining accepting pull requests with that, and that adds even more more risk because you're on your own.
Yeah. No, it's kind of a scary thing to set up, and I've been kind of slowly working my way through trying to think through this. Now I'm curious, does it actually send in pull requests to try to test some of this stuff, or is it just looking at configurations?
No, at the moment it's fully static. It's a static code analysis tool that works. It can work fully offline. In fact,
Okay.
it doesn't emit any network request except for interacting with Git. So you
Okay.
could Git clone everything in a
Hmm.
directory and disconnect from the internet and run Poutine. So like at the moment, we're not pulling any vulnerability database or whatever. It is in the roadmap to add that as a kind of opt-in feature where you would be like, dash dash allow synchronizing kind of vulnerability database. At the moment, we have that kind of baked in offline. Many of the rules are purely static code analysis, like to detect those problems, so they don't even need a vulnerability database. But yeah, so to answer your question, no, we are not doing any kind of active exploitation validation purely based on inspecting the code, finding the code patterns that are risky.
It seems like there could be, just looking at the problem from the outside and what little I know about Poutine, there could be some possibilities there where you might want it to be able to generate a. I guess that's tricky. If you want it to generate an active payload, then you kind of move into this area where Poutine becomes a Red Hat tool,
Sure.
or excuse me, a red team. Wow, I mixed my metaphors. Black hat, red team, but it becomes a red team tool. Maybe that's not what you as a security company want.
No, exactly. We've really designed it in a way that is gonna help people who typically are responsible for writing those workflows to detect problems quickly, efficiently, and learn from the. Like we've also provided some kind of training, like guidance and like best practice, kind of bad examples, good examples for people to improve. And in that regard, yeah, it is not designed as a red team to showcase that. That being said, we have a different project that we call Messy Poutine, if you want to get into that, which is all about allowing as a kind of a sandbox for capture the flag, where people can have fun exploiting things that we've designed to be vulnerable. And we built that really as a way to test Poutine. So we point Poutine to that GitHub, literally a GitHub organization called Messy Poutine. And it's all about finding as many flags, vulnerable things in there. There are some that at the moment Poutine is unable to find. I know them, like, and you can play the game kind of to find those. And we want to improve the tool to detect as many as possible going forward.
So, Francois, I'm curious about why you decided to release this as open source. What's the advantage of that for you guys?
Yeah, so we're a commercial, we're a vendor. We build a security product for a commercial product. As part of that, we automate provisioning a number of open source tools already. To name one, like SamGrep, for instance, or Trivy, or Gripe, things like that. Or Chekhov. So there's a number of open source tools that we help to orchestrate and aggregate the results, and then we add all of our kind of secret sauce on top of that. And that was, on the one hand, kind of give back to the community, because we've been benefiting from a lot of open source tools ourselves. And we wanted to bring something where we saw there was a gap, right? There was something that was not yet in the open source, and even in commercial, there's kind of a gap in that area at the moment. And we thought that this type of problem, when we started to look at it at scale, because that's how it really started. It started more like as a hackathon project where we knew this type of problem existed. We were finding it kind of purely manually, just by pure chance, like happening to see something, it's like, oh, that's exploitable. So we wanted to kind of automate that, seeing just how big the problem is at scale. And we started this project that we call Package Supply, which is indexing millions of open source projects and finding this type of problem at scale. So also finding transitive kind of attack path that is not directly targeting one project, but like vulnerable workflows that are downstream of an sensitive project. And at some point, when we had that, started to do a lot of responsible disclosures to many projects, we wanted to bring that to the masses, like to help people fix their workflows and find those things easily. So that's how we came up with Poutine as a sort of a sister project to this bigger kind of package supply, which I spoke at Open Source Security Foundation's conference last month about that project, and that was our way to give back to the community.
That's excellent. I was curious about how many people are interacting with it community-wise. What's the response been like? Have you had a lot of bug reports or interaction?
Yeah, so it's been just about a month that it's open source now,
Hmm.
and I think we're quite pleased with the number of interactions, like stars and like people like chatting about it, like, and you kind of getting interested in it. So it's, I think we're getting very good interest by people that I think should know it exists. But we want to spread the word even more, and thanks to you, like, hopefully we'll get
Hmm.
it to more
Yep.
people that can benefit from learning, even learning. Like, it's, I think it's first and foremost about awareness. Like, many people I talk to that have been doing pen testing, like red team exercise for years, they're completely unaware of this class of vulnerability. Many people, talk about OS top 10 and like very classic type of SQL injection, cross-site scripting, et cetera, et cetera. That's a very, very mature type of, area. Like, there's tons of tools. The know-how
Hmm.
is very, well advanced by now. But when it comes to vulnerabilities in build pipelines, that is still an area that is a bit up for grabs.
And you got to
In,
think, if red team professionals don't even know about it, then your run of the mill open source project on GitHub has no clue about it.
Yeah, I mean, and that goes back to this what we call package supply. That was
Mhm.
about in like doing evaluating the sheer scale of that problem at scale, like millions of projects. And as I said, we've reported a number of problems to open source projects. In some cases, some projects that were downloaded millions of times a day, like, not to name them, in very critical infrastructure kind of pieces. Like, so it is a real problem.
Yeah.
you mentioned in your, I read your blog when you announcing the release of Poutine, and you mentioned in there that it seems like maybe the things that you found so far feel a bit like they might be the tip of the iceberg. Do you think the industry's been kind of sleeping a bit on this as a potential problem, or do you think it's just not been in people's minds, or so?
Yeah, I think most people have been focusing a lot on making sure the code that they're producing, what they're delivering as an artifact, be it in open source or commercial, is secure. So they can, they do their best. But like, the build pipeline has always been seen more like as a means to an end, right? Like, you need to do it to automate certain things, to compile, to run tests, linting, and all that. But ultimately, a lot of times, like, even the build time components, like, they're not seen in the final artifact. So many people never thought this was much of a problem. But when you start to add, you know, you've all seen this kind of the sheer complexity in terms of dependencies, transitive dependencies of most current, like, in software nowadays, and you apply that to the build pipeline, it's the same thing. So the complexity and the problems we're trying to tackle when it comes to the code itself, um, they applies equally to the build pipeline.
It's interesting because people really don't, as you said there, people don't think about the pipeline. They only think about the end product and the code that's going to come out of it, or the source code that people are looking at. We don't necessarily think so much about how that gets transformed through these pipelines and can end up in, any kind of state, I suppose. I was reading earlier about the chain guard vulnerability that you guys discovered. I read that little blog post about it. Fascinating story. Can you tell us a little bit more about that? About the story?
Yeah. Yes. So we discovered that, like, as we were developing this tool, we were pointing it at the stuff that we're using. So it's a lot about developing a level of assurance that the things that we're consuming to build our product, we're picking the right, like, trustworthy components. And ChainGuard is doing an amazing job, like, great containers, like, secure by design and all that, like, and like with very low number of CVEs. But we were looking at their build pipelines, and we found one such example that was exploitable to the type of problem that I described earlier. But in that case, what was a bit more interesting is that we stopped short of the kind of end goal. Like the article I think you're referring to was a near miss incident, in the
That's
sense
right. Yeah.
that we got very close to the ultimate goal, which was to showcase, to demonstrate that we could exploit and backdoor, like compromise
Mm-hmm.
a component that themselves were using in the build pipeline of something that is like their mission critical, like Docker container machinery. And we stopped short of just like the one thing where, in fact, it was almost like it was a feature, not a security feature of GitHub Action that prevented us from, closing the gap. And that feature was made like by GitHub Action to prevent recursive kind of infinite loop. So it was not meant as a security like mitigation, but because like effectively a workflow using the default credentials cannot kind of trigger another workflow, um, like that prevented us from kind of closing the gap with the way the attack was set up. But it doesn't mean there are other scenarios where the credentials have the right permissions and you could have done that. So that's like a more advanced use case. But in fact, like just a month ago, a fellow competing research team, like it's his name is Adnan. Anyway, basically, he managed to find an alternative way to achieve the same goal. So it was very creative. In that case, he found that the caching mechanism in GitHub Action could be could lead to some kind of cache poisoning, where like you could basically add some vulnerable version of, in that case, the Go tool chain that would be used in another workflow, and like effectively you would have be using a poisoned cached tool chain.
Wow. I was I was curious about whether when we talked about the fact that it's open source and the benefits of that, and you're on GitHub yourselves. Poutine is on GitHub. I was curious. I have a bit of a mischievous question. Do you accept pull requests, or have you had pull requests? Is that a danger? Because Poutine itself, it seems to me, would be a desirable target for people.
Yeah.
Possibly.
Yeah, I think it really comes down, and I think that is why we built this Messy Poutine project, is to really educate people that there is a way to accept contributions from pull requests in a perfectly safe way. It's just that when you start to kind of go beyond the default scenario that is supported by default, you want to do some things that are a little bit like more like and more interactive. That's when you start to pull some credentials, and then the whole like least privilege kind of principle applies, where you don't want to put all your eggs in the same basket in that workflow that is a risky workflow that is touching credentials. That one you may want to separate it completely from the compile linter and like eventually release flow.
So you run Poutine against the Poutine repo from time to time?
Yeah, we've got like Putin on Putin pop.
Pop.
Yeah. So in thinking through this, it seems like kind of the worst case scenario that a security problem on one of these sort of build script the pipeline. The worst case scenario would be something like the XZ backdoor, where someone could sneak something like that in using a pull request. And I'm just curious, what's the worst thing that we've seen that's happened with kind of this style of vulnerability? Has there been, the XZ level of problem?
I mean, I would be shocked that it's not been already the case and no one knows about it, because every since I've been focusing our research on that area, every single day I'm shocked to see how easy, like how many low-hanging fruits are still out there, even on very reputable, mission critical piece of open source software that are maintained by, not to name them, pick a name of a big open source contributor, and I have concrete examples of vulnerable workflows that either I've reported they've been fixed, or that I'm in the middle of having them fix. So
Yeah.
it's we would be fools to think that attackers are not leveraging that already. And to that point, I've built some proof of concepts, like to demonstrate that to some of those, in the case of responsible disclosure, kind of a nightmare scenario example that was inspired by some of those things we've seen in real world. And I showcased that like in the last conference talks, like I have kind of a video explaining all that. And you can really see that it can be made extreme, like fully scripted, that the whole attack runs within just a few seconds, and the attacker can clean up their tracks, like cover as many traces as possible, so that what is left in the pull request appears completely like innocuous.
Hmm.
But in the end, the attack has fully succeeded, and it can be made in a very sneaky way. So just as much as XZ was more of a social engineering game, this could easily be combined with something fully scripted, automated, that
Yeah.
would be part of the whole operation.
Yeah. To kind of drill down into that a little bit more, um, one of the sneakiest things about XZ was that it wasn't an outside contributor. Well, he started as an outside contributor, but then he kind of worked his way into the core team, and so this is what we would call an insider threat. And I'm curious, what can we do, and is there anything that Poutine can help with to sort of protect from that insider threat?
Yeah, that's a much bigger problem. And
Yeah.
I think Putin is the only way that I see that Putin could help in the scenario of like an insider threat would be, imagine a scenario where the insider, malicious co-contributor, is purposely making the workflow vulnerable in a subtle way, right?
Mhm.
Like just like, oh look, I'm improving the GitHub Action workflow, let me do this, like it's going to be useful, and they knowingly add the vulnerability, which could potentially be detected by Putin. But Putin, is not perfect, and there are ways to write the vulnerability in a way that would not be detected. So in theory, someone using it to discover those kind of like vulnerable workflows that were added as a backdoor, like just waiting to be used,
Mhm.
that could be useful. Because again, there's tons of low-hanging fruits out there. So
Yeah.
were they maliciously added? Most likely not, but they're present, and they could be leveraged by someone with malicious intent. But for insider threats, I have another article for those who are interested that is all about addressing insider threats in open source projects. And that is a much more complicated topic.
Mm-hmm.
And then it comes down to some code review, like having like not just ideally like not just one maintainer, and like having like more than one person approving code changes. But as we've seen in XZ, it can be done in such a sneaky way that it passes community scrutiny.
Mm-hmm. And this is sort of a tangent, but one of the things that really, really interested me about the XZ story is part of the problem was hand built tarballs. And so if that project had instead used GitHub built tarballs, the whole attack would not, it could have been pulled off, but not in the same way that it was pulled off. And so it really fascinated me. We talk about reproducible builds, but reproducible tarball builds is sort of important too. And that seems like that is at least a parallel thought to what Poutine is working on.
Yes, and to that note, I called out one something very similar to that. Like literally 2 weeks before the whole XZ thing, I wrote this article about insider threats
Oh wow.
in open source project. And at the end, if you go to that article, at the end, I specifically call out what I wouldn't say it's a vulnerability, but it's a weakness or like a poor choice of the in design by GitHub's on GitHub's part when it comes to the release kind of and the GitHub like the release part, which where XZ kind of put this tarball, right?
Mhm.
Anyone that has write access to repo, like you just have a contributor that has normal write access, you may use branch protection to prevent them from merging code in the main branch, right?
Right.
But simply having write access allows you to modify release artifacts.
Oof.
So there is no specific role called release admin or release editor.
Hmm.
Anyone with write access can literally, I like just try it at home.
Yeah.
Just create a repo, create a release, create another user that you invite just as a write access person. Even if you kind of make it, it's not an admin and all that, they will be able to go and edit and upload another artifact. In that case, the exe, the tarball,
Hmm.
like literally you can override and it leaves no trace. There is nothing in the audit log of GitHub to see that it was tampered with.
Wow. Um, have you been able to get a hold of any of the security engineers at GitHub to talk through some of the various things
Yeah.
you've?
Many, yes, many times, including
Okay.
like 2 days ago, I met with some in person at the conference last month. So yes, I've been in talk with several people at GitHub, talking about a number of ideas that I have to improve at many levels. And they tell me that they're working on a number of initiatives,
Hmm.
but yeah, there's a lot of work to fix that.
Yeah. I do have a question from the chat room. I want to get to because I think it's fascinating. And it's from Ken McDonald. He says, "I see your documentation references an open source vulnerability database that's hosted at osv.dev. Is that database maintained by GitHub or Boost or you guys? What's the OSV?
So OSV is the open source vulnerability database maintained
Hmm.
by Google.
Aha.
So it's a osv.dev project, like you can find it. I think it's kind of a sister project to the deps.dev, if you're familiar with that other Google
Hmm.
project that is kind of tracking the dependencies, the dependency graph of open source projects. So OSV is really tracking CVEs, and there's a subset of it that is looking at GitHub Actions, namely. Um, and we effectively, so, because at the moment the number of CVEs for GitHub Actions is so small, literally less than 20,
Hmm.
we just we just pulled it offline. It's part of the Poutine binary itself. You can find it. It's just a JSON like file
Hmm.
because it's so small at the moment. So we don't even need to kind of go fetch some kind of vulnerability database updated every day because there's so few. But we know for a fact that there's plenty more to find. We find new ones, maybe not every day, but like especially GitHub Actions that workflows depend on that
Hmm.
are vulnerable. I have many yet to be reported, yet to be fixed.
Yeah. One of the other things that interested me is you guys are not with Poutine. It's not limited to GitHub. There's also GitLab support, and is there Azure support as well, or is that coming?
Yeah, at the moment we support GitLab pipelines, and we do have plans to support Circle CI, Azure pipelines,
Hmm.
and Jenkins and all that, and maybe in a different way. But at least like Azure pipeline is a low-hanging fruit because it's really the predecessor. It's kind of the parent of GitHub Action. Like
Ah.
when Microsoft acquired GitHub, they brought this, and that is kind of the underpinning of GitHub Action. GitLab pipeline, it's interesting because when we went and wanted to support it in Poutine, we wanted to find the equivalent vulnerability class
Hmm.
as the rules we were already supporting for GitHub. And there's a fundamental difference in the way GitLab pipeline are processed when
Hmm.
accepting pull requests, or in that case, they call it merge requests in GitLab, right? Accepting merge requests from forks, by default, they always run in a different context, which does not have access to secrets. So very similar to GitHub Action, what they call like pull request in GitHub Action versus pull request target. So it's as if GitLab by default does not have any way to expose the secrets when accepting contribution from a fork. But you're just one click away from saying, run it in the sensitive context. So in that case, it's a bit more like social engineering. Like you may want to hide it in a big PR with like hundreds of files and just one small line, like the XZ did, this kind of space, this extra white space at the beginning that changed the whole behavior of the bash script. So it could be very sneaky, and someone say, yeah, it looks fine. Let's run it in the guild pipeline with the sensitive context. So
Yeah.
yeah.
But one of the other differences that comes to mind is with GitLab, particularly if you're hosting GitLab yourself, you're not running all of that inside virtual machines. That's going to be, I would assume, what, in a Docker image or something similar. And so there's kind of another
Oh yeah.
another potential problem where you can escape whatever jail it is. It's going to be something like a chroot jail or a Docker image using namespaces, and depending upon how that's set up, those are escapable.
Absolutely. So yeah, whenever you mentioned earlier, like self-hosted runners, that puts a lot of responsibility on whomever is maintaining those runners to make sure they're fully airtight and nothing is being leaked between each run. Because if one run is poisoned and then you kind of sudo and backdoor the kind of environment around, then whatever follows is not to be trusted. So and that in that space, in fact, like we've seen like big projects, namely those who kind of need the self-hosted runners, because like Gen AI, like LLM, like projects, open source projects, they need like big machines with GPUs. And to save costs, like they kind of manage their cluster of GPUs on, say, AWS. So there's been a number of disclosures, not by my team, but by other teams doing research, where there were self-hosted runners on those open big LLM projects where you could basically poison the runner.
Yeah. I mentioned it earlier, but there's a scenario that's way simpler than that. Way less budget involved, and that is if you need ARM or ARM64 builds. You do not get ARM runners on GitHub, at least not for free. So for small projects, there's a real desire, for some of us at least, to do our own GitHub runners to be able to do ARM builds. I may try to get a hold of you offline outside of this discussion, because I'm trying to work through. I mentioned this earlier. I'm trying to work through how to set that up securely and maybe put a guide out on it. And it would be nice to get a sanity check on that before I tell people how to fix it.
Like I can quickly tell you, like the way most people do it, like in a securely not optimal way, is with QEMU. So they use QEMU to emulate ARM on the GitHub free hosted runner. So it's a lot slower, but it works. So that's a safe way to do it. To say like run compile on ARM.
Yeah, I suppose that's true. Okay, so I assume that you're kind of constantly folding your discoveries back into Poutine, because it's kind of one of those deals where you can only find the problems that are problems, and there's this whole infinity stretches before you with the number of different ways that GitHub and GitLab actions can be broken. And so is that just kind of a constant process of, we found another bad pattern, let's add this into Poutine?
Yeah, very much so. But it's always the back and forth between false positive and false negative. Any kind of scanner looking for code patterns effectively that are vulnerable, like if you add something, you may run the risk of finding things that are not a problem by
Yes.
as an accident, like you maybe a pattern that's a bit too broad, or vice versa, you're a bit too conservative and you're not finding the things that when you as a human just look at it, it's like, oh my God, it's obviously exploitable, but I never thought of that code pattern. And so yeah, we do go back from time to time and improve that.
Mhm.
But then like the more you add, there's performance consideration. So it's, but we do learn quite a bit with that machinery that I call like package supply. That is like
Mhm.
the big kind of large scale analysis machinery we have there. We have the ability to quickly run like kind of sniff test. Like sometimes I see something that just by observing it, like manual inspection, looks scary. Like I'm like, that's almost exploitable. And then I kind of generalize the pattern and apply like with the machiner to kind of scan it. And I cross the million projects, and within a few seconds I can come back and see, yeah, in fact, that one was not exploitable, but then there are 5,000 projects that appear to be very close to it. So it might require more like effort to manually validate it.
Yeah, interesting. Dan, did you want to jump in with a couple?
Sure, yeah. I was reading up about another project that you guys released open source called Living Off the Pipeline, which is a great name, by the way. Um, what is that, and how does it relate to Poutine?
Yeah, living up the pipeline, it relates in the sense that as we were doing more and more of those responsible disclosures, we started to find common patterns, namely when you're accepting contributions from a fork and you want to run tests, for instance, right? What are tests like, PyTest or whatever, any kind of test tool? Effectively, it's a binary that will take source code, execute it as in the context that those are tests. But then if the tests are modified by a contributor, they literally are, code execution by design, nothing more. So that is kind of an obvious scenario, like, and that is maybe too obvious.
Mhm.
But there are many tools that contain like little known features that most people don't even know about if they don't read the documentation in full, that are dangerous. Like namely, a number of even security tools have kind of power user features to configure them with plugins, for instance. I'm not going to name some because you can go and find in the Living Up the Pipeline project, and you'll find that some security tools you can configure the behavior with simply adding a file like dot, dot the name of the file that shall not be named, dot YAML, and you
Mhm.
can specify a plugin, and the plugin can literally be an arbitrary bash script or something. So then you run the tool thinking that it's just gonna, like, let's imagine Poutine had that feature, but
Mhm.
Poutine, like, we specifically designed it with that scenario in mind because we knew that other tools had made that mistake, so that we can safely run Poutine like even on untrusted code. But like in that case, if you can modify and add a malicious plugin on the fly, then
Mm.
yeah, it's a problem. So there are a number of examples you can find that. So it's really about creating an inventory of tools that CLIs, namely, that have features that are kind of foot guns, right? Like
Mhm.
Yeah. I was curious. We've already mentioned Messy Poutine, which is your capture the flag kind of project, if you like. But I want to talk a little bit more about that. If anyone listening to this is interested in maybe trying that, how would they go about that? And can you just tell us a little bit more about how they would get involved in that sort of thing?
yeah, so they would simply need a GitHub user account. They can create a different one if they want. In fact, I would
Secret one.
maybe, in that case, it's not so much important, but you can have different personas, kind of. But in
Mhm.
that case, this is really a victim project. It's meant to be an exploitable kind of goat project. If you're, in the web app kind of traditional thing, like you have
Mhm.
vulnerable web apps just for practicing education. So yeah, you just go to github.com/messy poutine in one word,
Hmm.
and you will find a number of repos and GitHub Action workflows and they're kind of like by levels, like level 0, 1, 2, 3. Some of them have like kind of interactions, by maybe one workflow might trigger another workflow as a side effect. So you start to play with it, like open pull request, like maybe put something fishy in the title, in the body of the pull request. I'm just giving hints. Imagine some kind of bash commands, maybe. So right, like you can kind of play with that, and the goal being to get the flag, you need to exfiltrate those secrets, which are only visible if you get remote code execution in the context of the runner. In some cases, they're as easy as they've been put as environment variables. So if you get remote code execution, you dump the environment variables, then you get the flag. In other cases, it's much more complex because you need to do a memory dump, like dump the memory of the process to get those secrets. Other cases, you need like much more advanced, like multi-stage attack. There's even one that's a self-hosted runner. If you want to practice, Jonathan, there is one that is a self-hosted runner thing, which I designed as a self-hosted runner on top of a hosted runner. So it's like a recursive thing. Anyway.
Excellent. So I wanted to ask you, being someone who's been involved in security and in open source for a lot of years, what kind of changes have you seen over the years? Has the job changed a lot as the kind of, new threats and new solutions arise? So that was one part of the question. The other bit, which is a really difficult bit of the question, which I won't blame you for skipping over, is do you have any predictions for the future of where all this is kind of going with these threats and vulnerabilities and things?
It's not end of year, like we don't do predictions. No, but yeah, I think the industry, since I started my career, I've been involved. My first open source project was 20 years ago. Like before the podcast, I went on and found my first message on a mailing list in 2004 with an OpenWRT project that was
Cool.
Wi-Fi dog. It was a captive portal that we were doing back then.
Yes.
Yeah.
As if by magic I happen to have a very old.
Oh my God! Like I like
remember those guys?
Shorting the pins and all that to reset it, and yeah, that's fun. But yeah, I guess I mentioned that OWASP top 10. There's like the average developer working at an average shop, like writing code, is gonna be forced to do some kind of OWASP top 10 training, even if it's like pre-canned boring training. It is not very useful, but at the very least, I think you can safely assume that most developers have at least heard what's an SQL injection, cross-site scripting, etc. So it becomes and there's just more like secure framework with secure by design. React is kind of preventing cross-site scripting by design, things like that. So and ORMs preventing SQL injection by design, etc. So it's just the industry is getting more mature for those low-hanging fruits. But it leaves the door, like the attackers just are moving on to the next weakest link. In that case, the supply chain is the new weakest link in the chain, literally, because it's getting harder to, even as an attacker, to not get caught. Like there's, more and more seams like, dumping lots of logs with web application firewalls, et cetera, et cetera. But meanwhile, build pipelines are just not as monitored in terms of their behavior, what's happening in there. Is some kind of malicious, like abnormal behavior. Yeah. So I don't know, to your other part prediction. Well, I think the prediction is that we're just starting to scratch the surface. Like as I said, I'm amazed at how many low-hanging fruits there are, but sometimes I catch not low-hanging fruits, but they still require me, let's say, 15 minutes to get past the non-obvious part.
Yeah.
But like.
Yeah, interesting. Okay, so I've got a project. This is not a contrived scenario. This is being pretty transparent here. I've got a project that I suspect has problems, and I want to run Poutine against it to kind of get a handle on what the problems are. What's the recommended way to do that?
Yeah, so basically Poutine, you can just get it, find it on GitHub, Boost Security IO slash Poutine.
Hmm.
You can run it as a Docker container or with Homebrew on Mac,
Hmm.
or you can build it build it from source yourself with Go. And then you just need a read-only token to GitHub or GitLab. uh, I would advise to create a on purpose just read only token just for that use case, and you point it to either the GitHub organization, and it will discover all the repos and that are public in that case. But if it's a
Oh.
token that has visibility into private repos, you can do just as much. So it will automatically discover the repos and iterate one by one. It will do a shallow git clone in a temporary directory.
Hmm.
So it's very much batteries included, like the level of effort to get from installing Putin or like just running it as a Docker container and finding obvious low-hanging fruits is very, very low, because you just point it to like the GitHub repo itself or the entire organization will scan the whole thing and return results within minutes. I designed it with testing on large organizations like Microsoft organization has like 5,000 repos and it takes about 15 minutes on 5,000 repos to return
Wow.
like the list of results. So it's like, because we do like shallow clone with just pulling the YAML. So, and that's very efficient.
Yeah. That's great. Along with that, if I find something that is a real vulnerability, would you guys like to hear about it? Do you have like a forum somewhere where people can say, "I found this thing and it saved our bacon, thanks"?
To report, you say you mean like if you found something in someone else's thing, or like in your own and you kind of fix it and
like
you're
in
happy?
like in my own, and I want to tell
Yeah.
you guys thank you. Like, is there a tip
Oh
jar somewhere
well.
or something like that?
No, not at the moment. It's but yeah, we don't have any kind of Patreon or kind of get up like
Yeah, buy
sponsor
me a
thing yet,
coffee or
but
something.
not
Yeah.
at the moment. But like if you come to Montreal, I'll buy you a poutine.
There you
Or you
go.
can buy me a poutine to thank me, and return the
Yeah.
favor with a beer or whatever.
Yeah, that sounds great. Does Boost Security offer this as part of their services? Like, is there a, hey, I want you guys to run Poutine once a week against all of my repos?
Yeah,
Is that sort of a service that's offered, or maybe that you're thinking about?
absolutely. It is part of our commercial offering. As I said before, our commercial offering is all about automating the orchestration of those static code analysis tools and aggregating the results. And as we did with other open source projects, Poutine is just one more scanner that we can easily have our customers provision, get the results in one dashboard, prioritize the results. Yeah.
Yeah, awesome. I was going to ask you to give us a 15-second commercial on what Boost Security is about, but I think you just did that.
Mhm.
So, I have a couple. I have, let's see, three closing questions I always like to ask. Now, you guys have only had this as open source software for about a month now, so
Mhm.
this one may be a category error. But I like to ask projects, what is the weirdest or most surprising thing that you've seen somebody do with the project?
Well, it's a bit too early maybe to tell, but
Right.
and I think, well, weirdest, I don't, I think one area that for those who are interested to want to play with the tool, try it. There's something we added recently that adds a lot more flexibility. We made it into like a pluggable architecture,
Hmm.
in a safe way. Like we designed it in a way that like you can basically configure um, other rules. Like you can kind of bring in your own custom rules or edit, modify existing
Hmm.
ones, and that could be used in a more creative way by someone saying, like your existing rules, they don't find what I know is a problem, or I
Hmm.
want to find like dangerous code patterns that are just like specific to my project. and it's possible using kind of the rule engine we've designed, like kind of a DSL sort of that is specific to GitHub Action or GitLab pipeline at the moment. So.
Yeah, interesting. All right, and the final two questions that we ask every guest: what is your favorite text editor and scripting language?
Yeah, Vim. VI guy. More.
Yeah.
Never understood the Emacs. Sorry. Just like it's already there whenever you SSH somewhere. It's very lightweight, and
Yeah.
I know how to exit Vim. It's fine.
And scripting language.
Python, like if we talk like scripting, but I really like Golang, like Poutine is implemented in Go, but more a script like to like rough kind of quick and dirty thing. Yeah, Python is my kind of go-to.
All right, excellent. Thank you so much for being here and presenting the project. A very neat project, and like I said, I think I need to run this because I have a feeling that we have some problems. So I appreciate you coming and telling us all about it.
Thank you.
All right, Dan, what do you think? Do you have some GitHub or GitLab projects that need this?
Well, I didn't think I did, but no, I probably do. I probably do. The more I think about it, yeah, really interesting project. I think it's great what they're doing, and it's an area that is definitely growing. I think in security and so on.
Yes. In the last few years, we've seen kind of these supply chain problems really start to be big deals. And I imagine, it interests me. He says, when we asked, do we see this being a huge problem with an XZ style? He goes, I would be surprised if it's not already, and we just haven't heard about it yet. It's like, that's the sort of thing that keeps me up at night. I'm glad there's people that are thinking about this and looking at it, and I'm thrilled that they decided to release this as open source. Get all of the eyeballs on it, and I'm sure if it hasn't happened yet, one of the things that's going to start happening is they'll get additional rules sent in from the community, and it'll make the project better for everybody. It's great.
Definitely, yeah, and it's what do they say? It takes a village to raise a child or something. I can't get that right now. I've forgotten the whole saying, but yeah, the more people involved, the better. Definitely, I would say.
I prefer the Linus Torvalds version of that rule, which is given enough eyeballs, all bugs are shallow. I like that one better.
Yeah. That would have been a better way of putting it. Yeah, I agree. But it's a fascinating project, definitely.
Yeah, it's great. Okay, Dan, do you have anything you want to plug?
Yeah, very quickly. I mentioned it last time I was here, I think, which is a little while ago, but Liverpool Make Fest, which I helped to organize, is a festival of technology and arts and all kinds of stuff. Lots of people building robots, and there's a guy making hot air balloons who's going to fly hot air balloons inside the building. I don't know if he's got clearance for that, but we'll find out. Health and safety is interesting for that event. But if you're in the UK, or you can get to the UK in July the 6th, it's coming up. It's completely free to come along and attend and get involved. There's workshops, there's all kinds of stuff. It's at liverpoolmakefest.org is the website, and that's the place for people to go and have a look. And I think that's about it. Yeah.
Dan, if somebody wants to follow you on the social media service formerly known as Twitter or Mastodon, is there a good place to do that?
At MethodDan is my username, but if you go to danlynch.org, which is my website, everything's listed on there.
All right.
I even managed to work out how to get a Mastodon feed embedded into my website, which took a little bit of JavaScript, which I was really proud of, which is probably really insecure. But there we go. Which I'll now have to go and test.
Yeah. Oh, that's fun. All right. Well, you can follow my work over at Hackaday, hackaday.com. We've got the security column that goes live every Friday, which I think this episode of Floss Weekly will probably get a plug in the security column. That'll be fun. We do not yet have a guest for next week. If you have recommendations or you're from a project and want to be on the show, it's floss@hackaday.com. Just shoot us an email and we will get you scheduled. Yeah, other than that, just want to say thank you to everyone that watches and listens, both live and on the download. We sure appreciate everybody. And we will see you next week on Floss Weekly.